The Ned Lloyd Asia on the Outer Elbe. The container ship has a load capacity of 3,600 TEU. A TEU is a standard container with a length of 20 feet or 6 meters. This ship can carry 3,600 such containers and is thus one of the smaller vessels. Trade via the internet and particularly the economic development in China led to enormous growth rates. Container shipping is booming. Efforts are made to lower transportation costs for each individual container by means of bigger and bigger ships. Can the giants of the future with their increased draft continue to call at German ports? Will ports cope with the logistic requirements? What technical problems arise when increasingly larger ships are built, and what changes for the crew?
If you look in the past, we had ships that take the amount of cargo which we take now as fuel, and you see that only the amount of people has decreased. Before we sailed on ships with 30 or 40 people, and now we sail on ships with 20 people. And if you see this ship and a ship of 8,000 TEU, it's also 20 people. The big job is the maintenance in the engine room. And as the engines get bigger, more cylinders, you've got more maintenance, more surveys to do. The other thing is with better technical innovations, that the maintenance can be reduced also.
How big will the container ships of the future be? With its 3,600 TEU, the Ned Lloyd Asia seems small in comparison to the 8,000 TEU giants currently being built. At the moment, ships having a size of 13,000 TEU are expected, and within the framework of a Dutch study, an 18,000 TEU vessel with a draft of 21 meters is already on the drawing board. Will ships of this gigantic size really be built in future? The Hamburg container port is located right in front of the Blue Star Shipping Company. Blue Star is a 100% subsidiary of P&O Ned Lloyd, the market leader on the Europe-Asia route. Currently, construction of 4 of the largest container ships with 8,450 TEU each is planned here. The Japanese shipyard carrying out the project has proposed a basic design. Changes in equipment are discussed at the shipping company that placed the order. In this way, efforts are made to optimize the ships for later operation. Of course, the desired changes repeatedly lead to discussions with the shipyard about the work required and costs. The close cooperation between the shipping company and shipyard continues throughout the entire construction period. The giants are built at the Japanese shipyard IHI Marine United in Kure, not far from Hiroshima. There's no shipyard in Germany that could build ships of this size. The Blue Star Shipping Company has a separate office at the shipyard for building supervision. From here, their staff support and monitor the construction of the ships and clarify questions that arise in direct contact with Hamburg. Even the construction of extremely large container ships begins with the plain delivery of steel plates. A total of nearly 40,000 tons of steel goes into each ship. Shaped parts are cut out of the steel plates with the help of computer-controlled flame cutters, and then bent if necessary according to the building plans. On the assembly line, the individually numbered steel plates are initially turned into small modules, which are then welded together to form larger and larger units. Only a few workers supervise the small welding robots that make part of the altogether over 800 kilometers of welded joints. The enormous preconceived blocks cannot actually be created out of the approximately 100,000 steel parts without carefully worked out logistic planning. The colossal giants are taken to the next production station by special transport vehicles. A shipyard is a workplace susceptible to accidents. Signs everywhere remind the workers about precautions for occupational safety. To protect the steel blocks against rust, they're carefully ground and subsequently sprayed with a primer. This is the first of a total of 5 coats of paint. The necessary pipe and electrical lines that will later run through the entire ship are already installed in the individual blocks. Around 40 kilometers of pipes and 300 kilometers of electric cables go into each ship. When the colossal steel elements are finally put together in dry dock, the connections have to fit precisely. Werner Enning also has his office at the shipyard. On site, he, along with his small team, represents Germanischer Lloyd, or as he says, GL. This is a classification and certification society that's comparable to Lloyd's Register of Shipping. At the shipyard, Enning checks aspects that are important for safety during later operation of the ship. We examine the quality of the ship on the basis of approved drawings and also the safety equipment on board. Furthermore, the welders are checked as well, of course. They have to take so-called welder's examination. Then the suppliers are checked by us. We carry out individual acceptance tests at these companies. In addition, we also work for the flag states. In this case, it's the country of Liberia. We check the entire safety equipment in accordance with Liberian regulations.
Welcome to the boat.
Sea trials with what is currently the largest container ship in the world. Nearly 100 workers and technicians come on board for the so-called sea trials in order to test whether the ship is operational and precisely check all technical equipment. The vessel leaves the shipyard for the first time. It's towed into the bay by tugboats.
We thank you very much up to now for all the cooperation.
The representatives of the client,
We are impressed.
those responsible at the shipyard, and the Germanischer Lloyd staff meet to discuss the test program for the next few days.
10 o'clock in the morning.
While the client desires a fast and flawless ship, the shipyard wants as little retouching work as possible. Germanischer Lloyd, in turn, only accepts a safe vessel. With a length of 335 meters, the ship is longer than the Eiffel Tower in Paris and has a width of nearly 43 meters. The sea trials are carried out without cargo. For the measurement of the maximum speed, on the other hand, the value is calculated with a full load. Meanwhile, the tugboats have taken their leave.
Wir haben jetzt das Werftgelände verlassen.
We've now left the shipyard grounds and the engine has just been started up for the first time for the sea trial. Now we slowly pick up speed, which is also indicated by the fact that black smoke occasionally comes out of the smokestack, like now. The smoke then becomes more constant after a while when the ship has picked up a little more speed. A roughly 40-meter shaft transmits the engine power to the propeller. The 93,000 HP common rail diesel engine with 12 cylinders is throttled down so that it generates the equivalent of around 63,000 kilowatts. In this innovative engine, the fuel injection is electronically controlled. The engine is thus economical, environmentally friendly, and can run extremely slowly, a big advantage when manoeuvring in the port. While the engine is run in, the shipyard technicians check the engine control system together with the client's technicians. A number of fault messages accumulate and are analysed to eliminate the causes. The main office of Germanischer Lloyd is not far away from the Hamburg harbour. More than half of the new container ships built are classified by this enterprise. Jan Olaf Probst works in the Research and Development Department. He advises customers regarding container ship design. An even larger ship with 13,000 TEU is being designed here. A simulation program calculates how the 380-metre-long vessel would behave in rough seas. What deformation, what stress occurs? In terms of the size of the propeller and engine, designers have already reached the limits of what is technically feasible. Therefore, two smaller engines, each with its own propeller, are to be installed next to one another. Traditionally, the deckhouse is placed above the engine at the stern. Now we've simply shifted the deckhouse to the front so as to couple the hull again. When the ship is in a swell, the two sides of the ship have different deformation characteristics, and at some point this difference becomes too large when the ship gets longer and longer. So we try to build some kind of closed section into the vessel. This is the deckhouse, which we place exactly between the side walls. As a result, an empty room is created below the deckhouse, where we cannot stow any containers. So we put the fuel here. This has the advantage that we also meet an ecological demand. There is no fuel at all in the outer shell. In other words, if a collision took place with the ship, no fuel would flow into the sea. In these buildings, people are less concerned with the technical feasibility than with the financial viability. MPC Capital assumes financing of the 4 container giants built in Japan to an investment volume of $320 million. So-called closed funds play a major role in the financing. Private investors acquire shares and in this way have an interest in the profits earned with the vessels. In the same way as if an individual buys such a ship, in these closed funds the financing is divided into an equity contribution and a borrowed capital share. The equity contribution is paid by the investors, while the borrowed capital is provided by banks. These ships, which were ordered in 2003, cost around $80 million. Of these 80 million, about 60 million are financed on a long-term basis by banks. Here again, the same principle applies that nowadays not only one bank assumes the risk, but the financing risk is shared by a pool of banks. And as a rule, financing is provided via international consortia. Turning maneuvers between the Japanese islands. The ship is tested to see how the steering system responds. On the bridge, the radar system is demonstrated to the client's technicians. The tests on the various shipboard equipment run around the clock. Everyone takes care of his section and takes a break when he has time. When darkness falls, the entire lighting system is checked. Then the anchors are tested.
So this is clear. Clear means the hoisting speed 9 meter per minute over case. Okay.
Rapid casting and hauling in of the mighty anchors is to be tested. Proper functioning of the anchor equipment is extremely important for safety. The worker carefully releases the brake. The dead weight pulls the anchor deep into the water. To ensure that the speed is not too high, the brake has to be applied repeatedly. Finally, the anchor is hauled in. This should be possible within a certain time for the vessel to be maneuverable again quickly. Everything is fine so far, but something unforeseeable happens with the second anchor. The worker releases the brake too much because the anchor doesn't respond at first. Once again, everything turned out all right. If the mighty chain had raced at full speed, it would have been torn out of the anchorage and hurled across the deck. So now we've checked the entire anchor equipment. First, for proper functioning, the brakes were tested, and just now the hauling in speed of the chains. We have to reach a speed of 9 meters a minute and actually achieve 10.5 meters. For us, this test is now over and everything is fine in this regard. The weather has changed. It's raining. The ship is making good headway and is slowly approaching its top speed. On the bridge, slight vibrations are felt. Although the engine has been throttled down, the Giant will later attain a cruising speed while loaded of 24 to 26 knots. That's nearly 50 kilometers an hour. The vibrations too are measured and examined precisely. 40 sensors are installed in different places in the deckhouse. The new common rail diesel engine proves itself, since the measured vibrations are fortunately minimal. After the long, intensive run, the engine was stopped and is now to be inspected meticulously. Several men climb inside the still very hot and oily engine. First, the enormous cylinder sleeves are examined for damage from the bottom. After that, the engine is opened further, so the technicians can take a closer look at the gigantic connecting rods.
Wir haben jetzt die Arbeit zur Installation am Voyage Data Recorder beendet und hier
The Voyage Data Recorder has just been installed. In accordance with international laws, in future all ships will have to transmit identification data and store data on their own and other ships' movements for 24 hours. This will facilitate the reconstruction of accidents at sea. Every cross represents a ship for which more detailed specifications can be obtained.
Das ist zum Beispiel ein Cargo-Ship, das ist 293 Meter lang, 46 Meter breit, hat dieses Rufzeichen.
In future, the shipping company will also be able to retrieve the detailed data on speed, course, cargo and much more online. This means it will always have a precise overview of the entire fleet. After an accident, this capsule could be retrieved and could then restore and play this data, like a film, and analyze what the cause was, comparable to the black box of an aircraft.
Analysieren, was war die Ursache.
Vergleichsweise mit der Blackbox von den Flugzeugen.
The black box will later be designed as a buoy that floats when the ship goes down and sends out a radio signal. The ship has passed its sea trials. Some small subsequent improvements have to be made. Apart from that, all those involved are satisfied. The container giant is towed to the dry dock for a final inspection of the outer shell. In the meantime, the representatives of the various groups on the ship draw up a report listing all the work that still has to be completed. The ship is manoeuvred precisely into the narrow dock. The gate closes and the workers again check the position of the ship before the water is drained. Now the hull and priming coat of the ship are examined. Paint must be applied to a total area of 500,000 square meters, or the equivalent of 70 soccer fields. During the sea trials, the ship sailed over its own anchor chain in this place. Primarily, painting work still remains to be carried out. This is quite normal with a newly built ship. In this case, it means somewhat more work because the shipyard has run into delays due to the great number of hurricanes that have swept across Japan in recent weeks and months, and as a result of the rain and strong winds, which have made work at the shipyard impossible. So-called anti-fouling coatings on the hull are gradually decomposed by the water over the years and prevent algae and mussels from adhering to the ship. In the water, these organisms grow on this uncoated surface after a few days. The original coatings were toxic and released substantial amounts of zinc in the water. Now, however, very effective and environmentally friendly coatings are used. In the design of a ship, special attention is devoted to the propeller in order to avoid so-called cavitation damage. During normal operation, the propeller may be damaged to the point of total loss due to this process. A model at the Hamburg Shipbuilding Testing Institute. It's in a closed water tank. The water is constantly pumped back to the model through this duct and turns the propeller. Due to the varying pressure conditions at the propeller, gas bubbles may evaporate and at the same time tear material out of the propeller. This test is aimed at making the cavitation symptoms visible. The shape of the propeller and of the hull determine the flow of the water and thus to what extent cavitation takes place. To permit more precise observation, the ambient light is reduced and a stroboscope lamp illuminates the propeller once per revolution. This makes it look as if the propeller were only turning slowly. The swarm of bubbles can be seen at the propeller blades. The experts quickly agree. The propeller makes a good impression.
Vortex going.
Yeah. It moves up exactly in the gap.
It looks like it's entering exactly here.
Yeah,
At the rudder.
exactly where we don't want it.
Yeah.
Nevertheless, there is a discussion as to whether the propeller can be optimized by slight changes in shape. Cameras installed in the water tank enable another perspective, but here again the overall positive assessment is confirmed. Nevertheless, the specialists decide to build windows in the stern of the real ship to be able to observe the propeller during operation. And this is what cavitation that causes damage looks like. Here we have an example where things look quite good in the test. Here we have another example of a large ship that has cavitation damage on the propeller. One can see how fine cloud-like particles of material come off here and peel off in strips. These are all indications of progressive cavitation damage. The Nedlloyd Asia approaches the port of Hamburg. At present, ships with a maximum draft of up to 12.5 meters can navigate the Elbe regardless of the tide. Of course, with the support of the tidal wave or with less cargo, larger ships are also able to reach the container port. There are plans to deepen the Elbe by an additional meter. Since ships in the future will be wider rather than deeper, there will be no need for further measures for a long time to come in the view of the Port Authority. Unloaded, the containers of an 8,450 TEU ship would fill a train over 50 kilometers long. Will ports be faced with new requirements? The shipping companies naturally hope that we will also be able to handle and clear their large ships with 12,000 TEU within 2 days. However, this means that we have to be 50% faster on the quay wall. And not only on the quay wall, since the real bottleneck at the container terminals in Europe today is the container warehouse. The question of whether the larger ships are profitable depends on how this problem is coped with. The Hamburg Port Operating Company is certain that the logistic challenges will be mastered, especially since its port is already the largest and most modern in Germany. Furthermore, it's assumed that the growth in vessel size will soon come to an end. The next step will presumably be 10,000. That can still be handled with the present engines and propellers, but that will be followed by a somewhat larger leap to a 14,000 TEU ship. There will definitely not be an 18,000 TEU ship in the next 10 years. How the development will continue is the subject of speculation, but one thing is clear. The Nedlloyd Manet, the second vessel of the 8,450 TEU series, will only temporarily be one of the largest container ships in the world.